Hello guys, this is the Maths Master and welcome to the first ever series of Maths and Science. Here I'll be proving to you that it's possible to get 100% in mathematics. And how do I know that? Because I also used to get 100% to a point whereby the learners in the neighboring school used to say that our teachers were giving us memos, but it was not so. And that's why I ended up getting more than 94% in mathematics and physical sciences. So this thing is simple, guys. All you need is consistency, practice every day and all day. You'll realize that if you do that in exactly 2 to 3 weeks time, you'll begin to realize that you are actually a better version of yourself. I'm not saying it will be easy. At first it will be complicated to a point whereby you want to give up. It happens to everyone. Even to me, it happens sometimes when I have to learn new topics. It becomes so complicated, but once I do it first time, second time, third time, fourth time, the fifth time, I'm already a master. So please don't give up just because it's difficult the first time round. And one thing that you must never underestimate is the power of repetition. You see, even if I give you, we do some sums here, and then later on, you repeat the same sums, obviously without looking at the memorandum. You repeat them. Then tomorrow you repeat the same thing. Then the day after you repeat the same thing. Never underestimate the power of repetition, guys. It's very powerful. So it's very easy to get 100% in mathematics and physical sciences. All you have to do is to just be consistent in whatever you do. So we'll be going through a few series, and one thing that I wanted to note was that I know that in most cases, especially with our teachers, they only pay attention to the top learners, in the class. So, but then you see, what I like about my class teacher was that he used to give us the personal attention we needed. It was as if we had our own private tutor, because school would start at 7:30 till 2, but after 2 he would still stay behind so that he can answer any of the questions that we had. And I remember at times we used to leave at school at around 9 p.m., sometimes even at 12 midnight, because our teacher was always there. So whenever we got stuck with something, we knew that he is just 2 steps away and he'll be able to correct us. So hence why I will be offering the opportunity to come and join me in my mentorship program. That's optional. If you feel like the videos are enough for you, then that's good. You can stick to the videos. But if you feel like you need a more personal approach and you need someone that you can always ask questions to and they'll elaborate further with videos and so forth, then I can be that guy. And I will basically teach you how to get your distinctions and your 90% and your 100%. It's possible to get 100%, guys. It's very possible. We used to get it every day. So anyway, we are not here to talk about my marks right now. The focus is on you. You are in grade 10 or 11 or 12 and you want to become the better version of yourself. So let's get onto it. So the topic that I want us to do is graphs. So I want us to go through one graph. I will be doing 4 series. I will be doing the hyperbola first, which is today, then the straight line, then the parabola, and then the cubic. So those are the 4 graphs that we have. And believe you me, once you watch these 4 videos, at the start of the first video, you will be able to master each and every graph. I'm telling you, I assure you on that one. So anyway, let's dive into it. As said, we'll be doing the hyperbola. What am I doing? Okay, hyperbola. So excuse my screen, guys, it's a bit slow. So I'll try to match the pace, because if I speak fast and then the screen is slow, it will be sort of as if there is an echo or a lag. So I don't want it to be like that. Anyway, so we have the hyperbola. In maths, before you start with each and every topic, you must want to know what is your general formula. Your general formula. So we know that with a straight line graph, our general formula is like this. Y is equals to mx plus c. This is our general formula. It doesn't have any values, just that we know that each and every graph that is regarded as a straight line has to have this kind of structure, right? So with the hyperbola, our general formula is what? Is equals to a over x minus p plus q. So with the hyperbola, this is our general graph. Always. So it must always have this structure for us to categorize it as the hyperbola. Otherwise, if it's not like this, it's most likely not a hyperbola. So anyway, let's say we have a graph like this, for example. So I want us to analyze something. 4 over x minus 2 plus 3. So let's say we have a hyperbola like this one, and then I want us to, what did I do? I'm sorry about that. Let me just turn this around. And add that 3. Yes. So let's say I've got something like this. Y is equals to 4 over x minus 2 plus 3. As you can see, this is a general hyperbola, nothing fancy here. So I want us to test what will happen to our graph if x minus 2 is equal to 0. So I want us to see what will happen to our graph if x minus 2 is equal to 0. Why am I choosing x minus 2 of all things? Why? Because I'm looking at this over 4 over here. So I'm taking everything that's here. I want to see what will happen if I equate this thing to 0, meaning we will say 4 over 0. So if I had x minus 3, I'd still say what will happen if x minus 3 was equal to 0. So I'm taking everything that's below here. So what would happen? Let me go back to my blue. So it means our graph will therefore be like this. Y is equals to 4 over 0 plus 3, because we went to where there is x minus 2 and substituted 0. So if you put this in a calculator, you'll realize that no, this gives us undefined. So it means therefore x minus 2 must never be equal to 0, right? So in other case, it means that x must not be equal to 2, because the only way that this whole thing will be equal to 0 is if x is 2. So in that case, it will be 2 minus 2. So x must never be equal to 0, because we know that once x becomes 0, it means we'll say 4 minus 2 minus 2 if x becomes 2. We'll say 4 minus 4 over 2 minus 2, which is 0, which makes our x 0. And we say that x minus 2 must never be equal to 0. Because why? It will give us undefined. Undefined. As you see that if we equate x minus 2 to 0, it gives us 4 over 0, which gives us undefined. So it must never be equal to 0. X minus 2 must never be equal to 0. So if, for example, I also had, I don't know what's happening with my screen, and it only does this when I'm recording. Otherwise, when I'm not recording, it works well. So if, for example, I had y is equals to 2 over x minus 1 plus 2. If I had something like this, I'd say, okay, the only way that I'll have an undefined here is if this below value, this denominator here, is equal to 0. So how can this be equal to 0? Is if x is 1. So, because it will be 1 minus 1. So, we know that x minus 1, this x minus 1, must never be equal to 0. And it can only be equal to 0 if we substitute 1 on x. So we must never substitute 1 on x. X must never be equal to 1 in other way. So that is what we call an asymptote. X is allowed to approach 1, but it must never be equal to. It's allowed to be 0,0000009, but it must never be equal to 1, because once it becomes 1, we will have an undefined, meaning it's 1 minus 1. But if it's 0,09, then we will have an answer of negative 0,01, you see. So that is how we find our x hyperbola, the x asymptote, I mean, sorry for that. So x must never be equal to 1. Okay, I'm gonna add a new page here. I hope you guys have copied this. I'm gonna add a new page. So let's say we had y is equals to, no, let me not use this color because I'm scared that the quality of the phone might affect this. So let me see. Y is equals to 3. So far we have never paid any attention to this number here. So let's say x minus 5 plus 1. So what can you guess the x asymptote for this? What must x not be equal to? X must not be equal to 5, because we know that if x is 5, then it will be 5 minus this 5 here. Then it will give us 0. So x must never be equal to 5. That is our x asymptote. Okay, let's go to the y asymptote. Let's start with this one. Let's start with this very same one. Okay, so we have y is equals to 3 over x minus 5. So I'm talking about this thing here. So I'm talking about this equation. So what if we say, we want to see what will happen if y is equals to 1. Where do I get this one? I got it from here, from this number here. So we want to see what will happen if y is equal to positive 1. So it means we'll have to go into this equation and substitute 1 where there is y. So I'll have 1 is equal to 3 over, so now I'm gonna leave x as it is because I'm not testing x now. I'm testing y. 5 plus 1. So it means now I must take this positive 1 to the other side. It will change and become negative. So we'll have 1 minus 1. So this 1 here is for this. Then this one comes here. Then is equal to 3 over x minus 5. So you guessed it, you will have 0 on this side. Then is equal to 3 over x minus 5. Now, when you have fractions like this, we can make this 0 into a fraction. We can just say over 1. We divided 0 by 1. It's still 0. Any number divided by 1 is that number. If I say 5 over 1, it's still 5. I didn't change it. So 0 over 1 is still 0. So I'm just making this so that it would be visible what we are cross multiplying with. So we'll cross multiply this one and this one and this one and this one. So we'll say 0 times x is 0. 0 times 5 is still 0. So everything on this side will be 0. Then 1 times 3 will have 3. What happened? Is 0 equal to 3? Not possible. It's not possible. 0 can never be equal to 3. So what does it mean? It means since we are getting a very strange answer, a mathematical error in such a way, it means therefore y must never be equal to 1. It means this is our y asymptote. So this number here, what did I do again? So this number here must never be equal to, y must never be equal to this number that's at the end. It must never be equal to. Why? Because when it's equal to this, it means we will come to a situation whereby we have 0 on the other side, always. And then we'll say 0 times that number, and then we'll end up having an unequal equation, you see. Always. So y must never be equal to 1. I hope you wrote it down. Let me go through to another page. And then let's do another example. Okay, so let's see y is equal to 5 over x plus 1. Let's say in this case where this number here is minus 3. So I want us to substitute y is equals to minus 3. I want to see if we'll still have the same thing. So I'm making y equal to this number here. So I'm gonna have minus 3 is equals to 5 over x plus 1. Then because then minus 3. So as you can see, it means I'm gonna take this negative 3 to the other side, then it will be positive. So I'll have negative 3, which is for this, then plus 3. So it was this negative 3, it changed sign and went to the other side. Then 5 over x plus 1. And what is negative 3 plus 3? 0 is equal to 5 over x plus 1. And then let's cross multiply. Let's make this over 1 and cross multiply. This one with that will have 0 is equals to this one with that will have 5. But we know that 0 is not equal to 5. So therefore, what should we say? We should say therefore y must never be equal to that -3, because you see, you've seen what happened when we make y equal to the number that's at the far right. So we must never make it equal to the number that's at the far right. Why? Because that number is always the y asymptote. Y must never be equal to that number. That's what asymptote means. So if I have y is equal to 1 over x minus, or in this case, let me say plus 2 plus 4. Then they say, write down the x and y asymptote. Remember, x, if you want the x asymptote, we must say which number can we substitute here on x to make this whole thing 0, because we know that the only thing that this thing will be undefined is if we divide by 0. So we make this whole thing 0. Which number is that? It's -2. So if x becomes -2, we know that we'll have 0 here, because it will be -2 plus 2, which is 0. So x must never be equal to -2. That is our asymptote. And then also, let me change the color. And then also, we said y must never be equal to +4, because we have seen what happens when y becomes this number here, +4. It will give us 0 on the other side, then we'll cross multiply, and then we'll get equations that are unbalanced. So we have two not hyperbola asymptotes here, the x asymptote and the y asymptote. And the x is -2, the y is +4. Now let me make a new page. And then scroll down. I have to do it slowly. Yes. Okay, so let's do another example. Let's say we have y is equals to -1 over 5 plus x plus 6. Then they ask us, what is the x asymptote? Remember, x asymptote is that number that we must never substitute here to make this thing 0. So which number can we substitute here that will make sure that this whole thing becomes 0? Is -5. It can't be 5, because if we say 5, then it will be 5 plus 5, which is 10. But if we say x is -5, it will be 5 minus 5. So it's x is equals to -5. That's the asymptote, the x asymptote for this graph. And what about y? Y is simple. We don't change anything. It's always equal to this number here. So y is equals to +6. Simple. Always, always, always. So now we know how to get our x and y asymptotes. That's good. That's good. Because we only need 3 things to get our graph, to be able to draw our graph. We need the x asymptote, we need the y asymptote, which so far we are able to get. And then after that, we need to find out on which quadrant does this graph have to be drawn on. Okay, so let me give you a tip for that. Remember, we said the general rule or the general equation is like this, plus q. So it means p is the x asymptote, q is the y asymptote. Then now it's time to talk about a. So a is the one that determines where we draw our graph. Ne? So let's say we have a Cartesian plane like this and another Cartesian plane like this. This is how we label our quadrants. Our quadrants are labeled as 1, 2, 3, 4. 1, 2, 3, 4. So it's always like this, always like this. So rule of the thumb is that if A is positive, then we are gonna draw the graph on 1 and 3, meaning it will be something like this, 1 and 3. But if A is negative, we are gonna draw the graph on 2 and 4, like this. So a hyperbola can either be like this or like this. There is no other shape. There is no other shape. And remember I said for our hyperbola to be like this, it means to be like this. It means our A must have been greater than 0 or must have been positive. And then for this one here, I said our A must have been less than 0, meaning negative. Any number that's less than 0 is negative. So let me write the positives and the negatives for in case some do not understand these inequalities. So we only draw this type of graph here if our A is positive, and then this one here if our A is negative. This is basically the same thing as this and this. And also, you see, I drew the graphs like this, but that doesn't mean that these graphs must never cross the x-axis and the y-axis. They can cross them. The only thing that these graphs are not allowed to touch are the asymptotes. So if, for example, I had a graph like this, and then let me draw my asymptote. Let's say we got, let me draw the asymptote of one graph. So I want us to draw this graph here. Let's draw this graph. Y is equals to negative 1 over 5 plus x plus 6. We already know the x and y asymptote. So the x asymptote is negative 5 and the y is positive 6. So x is negative 5. So negative 5 is somewhere around here. Negative 5. I'm not able to draw properly here. Negative 5. So why do they call this line negative 5? Because anywhere on this line, the x value will always be equal to negative 5. If I want to find this point, let me use a different color. If I want to find this point here, it will be negative 5 and something. See? If I want to find this point here, it will be negative 5 and negative y something. So anywhere on this line, the graph, or anywhere on this line, the point will always have a negative 5 as an x value. So anyway, that's our x asymptote. And remember, our y asymptote was positive 6. So let's say positive 6. Let's make it green. Positive 6 is here. That's 6. So remember when I said the graph can either be like this or like this. So it can either be quadrant 1, 1 and 3, or 2 and 4, right? So I was referring to the quadrants when looking at the asymptotes, not the x-axis. So I'm not gonna count my quadrants as 1, 2, 3, 4. No. I'm not gonna count my quadrant like that. I'm gonna look at the intersection of my x asymptote and y asymptote here. Then I'm gonna say, okay, it means my first quadrant is like this, 1. Second quadrant, 2. Third, 3. Then fourth. So I was referring to the intersection at the asymptotes. That's how we will be counting our quadrants, not the intersection of the axes. I want to make that one clear. This is very important. So it means, since, if you can check, remember it depends on our a. It depends on our a. So in this case, our a was -1. -1. So since it's negative, what's happening here? So since it's negative, it means that it will be, let me look for another color. Since it's negative, we said negative is at quadrant 2 and 3. And where is our quadrant 2? Quadrant 2 is here. This is quadrant 2 and 4. Quadrant 2 and 4. Where do we get this? We get it from here. From here. Quadrant 2 and 4. If our A was positive, then we were gonna draw it on 1 and 3. But in this case, it was negative. And be careful. You must make sure that this graph here, our graph, does not cross this red line and the green line. Why? Because they are our asymptotes. The graph is not allowed to touch the asymptote. But as for the x-axis and the y-axis, they are allowed to touch. They are allowed to cross. So it's not a problem. They can go like this. That's not a problem. But the minute you make it go like that, they're gonna give you 0. Why? Because that's the asymptote. It's not allowed to touch it. I hope that makes sense. That's how we draw the graph. Easy. And these are basically the only things that they always ask. Find the x-axis, not the x-axis, x-asymptote, y-asymptote, then draw the graph. So if you understand me so far, then it means that you are ready to get 100% in the hyperbola. Now let us do another example. Let me hide this. So I'm gonna do one example with you guys. So now I'm gonna be covering everything that you have done so far. So let's say I have y is equals to 2 over x minus 3 plus 1. Okay, so from this, what is our y asymptote? We know that y asymptote is always this number here. So y must never be equal to +1. And our x asymptote, remember, x is the number that we can substitute on this value here so that this whole thing becomes 0. So it's going to be 3, because then we will say 3 minus 3, which gives us 0. So it means our x is +3. Yes, we were able to find our y asymptote and the x asymptote. Now, what do we need? We need to know what a is. Is a positive or is a negative? And we know that if a is positive, then it will be on quadrant 1 and 2 of the asymptote intersection. And if a is negative, it will be on quadrant 2 and 4 of the asymptote intersection. So if it's positive, it's on 1 and 3. And if it's negative, it's on 2 and 4. So what is a in this case? A is positive. So it means for us to draw our graph, it will be like this. and then we will draw our asymptotes. Let's say, okay, x asymptote, x is positive 3. Positive 3 is here. So it will be like this. And then y asymptote, y is what? Positive 1. Positive 1 is here. So y is always horizontal, and then when talking in terms of asymptote, y is always horizontal, and then x asymptote is always vertical. Then remember, we use this point here as our reference point. It means this is quadrant 1, this is quadrant 2, 3, and 4. Then we are able to draw our graph now. Let me choose pink. Remember, our A in this case, A is positive, right? So I said if it's positive, then it means that it will be on quadrant 1, which is this one. And remember, it must not touch the red and green line. And then it's on 1 and 3, so it will also go like this. It's allowed to touch the blue line. Why? Because the blue line is the x and y axis. That one is allowed to touch, because they can ask you then, what is x axis? What is the x axis? X axis, y is equals to 0. What is the y axis? Y axis, x is equals to 0. So it's allowed to touch the blue. But as for the red and green, it's not allowed to touch, because we realized when we tested at the beginning that it always gives us undefined answers if it's equal to the the asymptotes. So yeah, this is the hyperbola, guys. This is the hyperbola. If you have any question, please do not be afraid to ask in the comments. And if you are interested in joining my mentorship program, you are more than welcome to give me an email. Let me write my email here. So it's the Maths Master that's R at the end there, the Maths Master at gmail.com. That's my email, guys. I hope you enjoyed the session, and feel free to ask any question that you may have. As you can see, this is easy. This is easy stuff. If you want to get 100%, this is how you'll be able to get it, one step at a time. You teach yourself how to get 100% in hyperbola, then teach yourself how to get 100% in parabola, then teach yourself how to get 100% in the cubic function. Don't do everything all at once. What I've seen students do is that they want to finish the whole question paper in one day. No, you don't do that. What you should do is do all the questions that involve the hyperbola from since 2008 till now. And I promise you, once you do 2 or 3 questions, you'll realize something. And that is that examiners always repeat questions. I promise you, once you do 3 questions, in the 4th one, you'll be able to get 100%. That one I guarantee. And then once you have done all of them from 2008 till 2021, then move to the next topic. Do parabola. Focus on parabola for that week or that 2 days to 3 days. And then do question papers from 2008 until 2021. After doing 3 questions, you'll realize that the examiners always ask 1 question. And why is that? Because they have a responsibility to make sure that the question papers are standardized, you see. So which means this year's question paper should not be too different compared to last year's question paper, and also not too different to next year's question paper. Otherwise, if they are different, it means the standard is not the same, and therefore it means that if another metric class received easier questions and the other one received hard questions only, it's not standardized. The other ones were treated unfairly. So that's why after marking, when they get to the marking center, the teachers get together and they talk about questions and they analyze and say, no, but then question 5 was a bit above standard. So let us give each learner 5 marks for at least attempting it. That's what they do always. That's why you can get 40% or let's not say 40%. No one is gonna get 40% here. You can get 80% and then you do a remark. Then when you do a remark, you only realize that no, you actually got 75%. But your reflection was 80%. Why is that? Because they gave you extra marks. They gave everyone extra marks because they realized that no, this question was a bit unfair. So let us give all the learners 5 marks. The examiners always ask one question. And to be honest with you, for me, I finished my syllabus in grade 11. In grade 11, I was already done with the grade 12 syllabus. So I spent the whole year doing revision. And one of the reasons why I was able to get 100% from January to December was because I was basically doing revision. None of the questions that they asked in matric surprised me. Why? Because I have done all the questions from 2004 up until the time I matriculated. So if you also want to get the same marks, make sure that you do previous question papers, and after some time, as I said, 3 questions, then you'll realize that they will always ask the same questions. So anyway, that's it from me, guys. I hope you enjoyed the session. Please click on subscribe. Please send me an email if you want personal mentorship. Please tell me how I can improve with regards to how I offer my lessons. I look forward to hearing from you. This is the Maths Master, and bows.